Hi, everybody. Good evening. Welcome to today's Swiflearn class. And this is of the class extended science of electricity and electric circuit. So I think let's start. Okay, so I'll just share my screen. I hope everybody is good and well. I hope everybody is fine. Uh, okay. So you can if you want to say anything, you want to comment or ask any doubt, you can ask it in the comment section below. So I'll be reading all of them. So let's start. How's it, guys? Okay. So let me just share my screen. Hmm. Okay. So let me just say something about Swiflearn before I start and get into the class. We all know that Swiflearn is 100% live and interactive classes. And then we have personalized attention of maximum only 6 students in a batch. And then we have also a dedicated team member of a lot of dedicated teachers who are teaching in our panel. Then we also cover syllabus as per the school exam schedule and also handle the custom request. So these are some of the key features of Swiflearn program. Now, some important thing that you all should be knowing about Swiflearn is that we have a detailed progress report after each class. Then we also conduct academic test series SATs. Then we also have subjective tests for school exams, and we take also unlimited practice test. And the main and the best feature of Swiflearn is that we can actually have a free trial class before we want to join and have paid classes. You can actually have a book a trial class and see if you are okay with the classes, the teachers, and the content material and the teaching. So that's a very good idea, right? So you all can try it, and if you want to, or if you're looking for a very good tuition, or if you're looking for a very good education platform. So that's it about Learn. And if you like the video, you have watched all these while any live, if you have watched, you can actually subscribe to our channel, then press the bell icon, and so you can never miss an update. So that's good, right? So I hope everybody is doing good. So let's start. What we are going to do is about electricity and circuit, the third part. So, what do you know about electricity, children? Any idea what is electricity and circuit? What do you think about it? I'll just like to know some opinions or answers in the chat session. I'll be reading them. Anybody tell me what is electricity or what is electricity and circuit? Or you can tell what you learned in the last class. This is the third portion, right? So you might have learned the electricity and circuit and more of it in the previous sessions. Can you please tell me what do you think about electricity? Anybody? Okay, I'm just looking your chat. Okay. Yes. Okay, good. So, what we will be learning for our today's session is the revision of earlier concept, what all we have learned. Then we'll learn about dry cell. Then we'll be learning about various uses of dry cell. Then we'll be learning about electricity, then electric cell and the battery. What are the difference between electric cell and the battery? Then we're also learning about the impact of dry cell if we both join the terminal directly with the wire. We will learn what is torch. We all see what is torch, but what exactly is happening inside, we will see today. Then working of a torch and what is happening. Then insulation of conducting wire. All that we'll be learning today. Okay. So sounds exciting, children. Anybody? Everybody sounds good about it. Uh, okay. So let me just start. Anyways, in the previous class, what we learned about conducting and insulating material, right? So I hope you all remember it. And if you have any doubt, you can ask me, okay, in the chat box. I'll be just reading them. And you can also try to revise or recollect what you have learned about the flow of electric current, then the conductions tester, then a switch and its function, how it works, all that we have learned in the last class, right? Anyways, let's recall the main important one which we learned last time is that difference between an electric cell and a battery. What exactly is the difference between electric cell and a battery? Anybody? Try to recollect and give some answers which you think is right. I'll be just reading out aloud also. So what do you think about the difference between electric cell and a battery? Let me know. Okay. Okay, fine. So yes, cell and a battery, mainly in cell that we have to see, it's a singular unit that produces electric current, right? And in battery, what is it? It is It is a battery that is composed of many cells. Okay. Then in a cell, it can be a battery. A cell can always be a battery, but a battery can never be a cell. So that is a highlight here which you have to always remember. A cell can always be a battery, but battery can never be a cell. Understood? So the symbol here of a cell is it's just one cell, right? It's just a single unit. So it's just that one positive terminal and one negative terminal. That is how we will be showing about the cell. And the battery here, that is, it'll be a group of cells that is combined and joined together, right? So that is how a battery is. That is, see, this is one unit of cell, this is another unit, and this is another unit. So all these joined together is a battery. Okay. Now, the cell is having a positive and negative terminal, just one positive and negative terminal. But here the battery is having here two cells, and again each of them are having positive terminal and negative terminal. Okay, children. Now, we'll connect the bulb and electric cell and conducting wires. How will we connect it, or which is the correct way to connect it? Anybody has any idea how is the correct way to connect it? Yes, I'm looking for some answers. What is the correct way to connect it? Anybody? Yes, it is. If we connect them in a complete proper manner, then we will get a closed circuit. Okay. So if we do not connect it in in a proper manner, we'll be getting an open circuit which will not conduct the electricity properly and will not let the bulb glow. But here in the closed circuit, the bulb will always glow. Why? Because there is no gap in between the connections. And why? Because it is connected in a proper way. Now we'll see what exactly is that proper way. Okay. So now we have in our hand a cell, a bulb, and a wire. So with these three things, we can connect it and actually we can get a glowing bulb. So if you do it in the right way, we can get that. So how is the right way to do it? I'll just show you. That is, just keep this cell here and the negative terminal from here, you will connect it to this portion, and the positive terminal, one wire, you will be connecting it to here. There is a terminal here. Okay, so since here like this, the electricity will be flowing and it will be lightened up. The bulb will glow. Okay, children? Now, let's move on to dry cell. Okay, what exactly is dry cell? Anybody? Everybody can give your answers. You can just guess. It's okay if it is wrong also, fine. I'll be here to correct you. That is why I'm here, right? So it's okay if your answers are wrong. I'll be just correcting you. Anybody knows what is a dry cell? Yeah. Okay. Yeah, exactly. The electric cell which we use in torch is known as a dry cell. Okay. Now, why is it called a dry cell? Any idea about that? Why exactly is it called a dry cell? Okay. Anybody has any idea why is it called a dry cell? Maybe it can be just called a cell, right? Why a dry cell? It should be some reason behind it, no? The reason is nothing but it's there in the name itself that it does not contain any liquid chemical. So that is exactly why it is called a dry cell. Okay. If there was any liquid chemicals present in the cell, then it would have been called maybe a cell or a liquid cell. We don't know because that never happened. But here there is no liquid chemical present. That is exactly why we are calling it a dry cell. Understood, children? Okay, very good. So now this dry cell, we just see some characteristics of a dry cell. How exactly is it looking? What are the characteristics? What all are present in it? All that we'll be just looking into an overview. Now this electric cell is a cylindrical device. See, you can see. You have seen no this battery cell and all in your remote, then in your maybe the alarm clock which you use. All that you'll be seeing this dry cell, right? This electric cell is a cylindrical device. Okay, it'll be having a small metal cap. Now I'll just show you where is the small metal cap. See, this is the small metal cap. So this small metal cap is present here in the positive terminal. Okay, and another metal disc on the other side. Okay, this is how the dry cell is. Now, this electric cell has two terminals, that is positive and negative. Okay, just like that before I showed you, positive here and negative here. So these are the main characteristics maybe you can tell about the dry cell. Now, see, this positive terminal is always having a metal cap. Okay, that is how a dry cell is made. And this negative terminal here, right, that will be having a metal disc. This is the metal disc here, and this is here the metal cap. And here this metal disc is a negative terminal, and this metal cap is a positive terminal. Okay, so understood this, children? Any doubt till this much you felt, or you want to clear any doubt? You can just ask me in the comment session. Yes, any doubt, children? Anything you want to clear or interact? Okay, so I think nobody has any doubt. That's great. Okay, good going, no problem. So now, this dry cell, how does the dry cell exactly conduct electricity, or what is exactly happening inside? How is this dry cell, when it is connected to a remote, how is it working? What exactly is happening in this small dry cell? Let's get into that. Now, this electric cell produces electricity from the chemicals that are stored. So you should always understand this dry cell consists of so many chemicals. Okay, so these chemicals will be stored inside those cells, and from there only the electricity is produced. Now, when all the chemicals in the electric cell are used up, the electric cell will stop producing electricity. So just like I told you before, the chemicals that are present in the cell, right? Those cell will be, what do you say, used up completely. So after it is used up completely, what will happen? It will stop producing electricity because there is no product or chemicals present, right? So that is why it will stop producing electricity after the chemical is used up completely. Okay. Now the ordinary cells cannot be recharged. That is also something which we have to keep in our mind. Okay. Now this dry cells, where do we use it? Any idea? You have seen, right? Like most of these cells you have used. Where do you use it mostly? TV remote, obviously, alarm clock. Then you can also use it in the torch, right? So all these things we can use the dry cell. Maybe some or other example, if you say the wrist watches, then alarm clocks, transistors, radios, TV remotes, camera, toys, and all these other devices, we can use a dry cell. Okay. Now, why the electric cell is named as a dry cell? We discussed before. So why is it named as a dry cell? Like anybody can give your answers. It's okay even if it is wrong. Come on, you're learning, no, and it's for the first time, so it's okay. Why is it called a dry cell? Anybody? Answers, please. I would love to see your answers. Okay. Yes, exactly. Why? Because it does not contain any liquid chemicals. That we can understand from the name also. Dry cell meaning no liquid chemicals. Okay, so it's all fully dry inside the cell. So that is exactly why it is called as a dry cell. Okay, because it don't have a free liquid electrolyte, just like how I was discussing before. Now, how should we connect this battery, or how should we get a proper circuit or terminal? That we will be getting into it now. We should always join this two terminal. Okay, how? By connecting them through wires containing a device, that is such as a torch, bulb, and a switch. Now I'll just show you here. This here is the switch, this here is the bulb, and this here is the battery. Now what we are going to do? See now, yeah, now we will put this cell here. Okay, correct in the position. We put the switch here. Now we are connecting the bulb. Okay, so when you're connecting this bulb, this circuit becomes a closed circuit. Okay, it's becoming a closed circuit. So after that, what will happen? It will get lightened up. Okay. So one thing that we should be very careful is that we should never join the two terminals of a cell directly by a wire. Why? Why? Because if we do that, then the chemicals present in the cell will be used up very fast and the cell will get damaged, right? So we should never connect the two terminals of a cell directly by a wire. Understood? Okay, no problem. Okay. So what happens if we connect the both terminals by a wire? What will happen? What are the observations? That cell will get heated up and then cell no longer will be active. It will get damaged. Okay, so that we should never connect them both terminals by a wire. So here we can see the flow of electricity. See the negative terminal, it's going like this. The current is flowing and it is going to the positive terminal. Here you can see there is an insulated casing. Okay, so that we would not be getting any current or any accidental shock. Okay, so that is why we are having this insulated casing. Okay, so this negative terminal, from here the current will be flowing and going to the positive terminal. Okay, so understood this, right, children? Okay. Okay. So now let's see. Do you know any idea how this torch is working, children? Any idea? Any answers? Let me see your answers. Okay. Let's see. Yeah, now we will discover this. How does a torch work? So now let's have a look inside the torch. What is exactly happening? Okay. So here the switch is on and then the light will be produced from here. Okay. So after this, what is happening exactly? We will be looking into it. That is the working of a torch. Any idea, children, how a torch is working? What exactly is happening inside? I would love to see your answers. Any idea? Let me see. Okay. Okay, anybody working off a torch? How does this happen? How does a torch work? Okay. No problem. You can answer, Sarthak. No problem. You can answer now again. Any idea how is the working of a torch? Okay, I'll start. So, how this torch works exactly is that when there is two terminals of a cell, right? Those two terminals of that cell will be connected to the two terminals of a torch. Okay, how the torch bulb is there, right? That bulb will be connecting them by using wires. So by using the wires, now the electric current will be passing through the filament of the bulb and then it will start glowing. So that is how the working of the torch happens. So first we will connect the terminals of the cells to the terminals of the torch bulb, and that time what will happen? The electricity will start flowing. So when the electricity starts flowing, it will reach the filament and then the bulb will start glowing. Okay. Now, the torch bulb, when it lights up, the metal tip, right? That metal tip and metal case are connected through the wire. So that is connected and that's how the torch bulb will be lighting up. Okay. Now, when the electric current passes from one cell through the filament of the bulb, the filament gets heated too much, right? Why? Because there is flow of electricity and the heating capacity again increases. When there is flow of electricity, the heating also, the wires connected or the filament also gets heated up very fast, right? So there the filament will get heated up that much. Now, when the filament is getting heated up, what will happen? It'll become white and hot, and then it'll start giving too much of light. So it is this heating effect produced by that electricity from the cell which will make a torch bulb work. And this is how the light will be produced. Okay, children, understood? Very good. Now, a torch bulb will always convert electricity into light. So how is this being done? That is by the filament getting heated up. So here I will just show you, this is the filament. Okay, so this filament is getting heated up. Okay, that is how the working of torch also takes place after the filament getting heated up. Now, so now here you can see this filament will be connected to two terminals, no? And then the electric bulb will be glowing when the electric current passes through it. Now the small amount of electricity produced by these two or more dry cells can light up only a small electric bulb like a bulb torch. It cannot light up like a big tube light or anything. It can only light up a bulb torch. Now, it cannot, exactly like how I was telling, it cannot light up the big electric bulb which we use for lighting in our house. So, understood how the cells are working in a torch and how all this works together? This is exactly why. Okay? Now, any idea why there is a plastic coating on the conducting wires? Any idea, anybody? Any answers? Anybody? You can give your answers in the comment box. I'll just be reading them. Yes, looking for answers. Anybody? Okay. So that is exactly why. It is because these wires are being very conductive material they'll be having. Okay. So the copper conducting wire here, just like I will show you here also, there is a copper conducting wire. So this copper conducting wire will be very highly, conducting the electricity. So that time, if you go in case touch it also, there will be a flow of electric current, and that is will be getting shock. So to avoid that shock being produced from that conducting wire, there is insulation around the copper wire. Okay, so that is exactly why there is insulation. Understood, children? Okay. Now, this electric wires are having a plastic insulation over them because of the following reason. Why? In order to use the electric wires in electric circuit, some of the insulation from both each end of the piece of wire has to be removed to bear for making connection. So here I'll show you all the wires will be having all the insulation. But that insulation we have to remove at the end. Why? Because it has to be connected bare. And without the insulation, then only proper flow of electricity will be there. Understood? Now, the bare end of the electric wire can be connected to the two terminals of a cell. So there are two terminals of a cell, and that time it can be connected. Okay, by using what? A rubber band or adhesive tape used by electricians. Okay, so that is how we will connect the bare ends of the insulated wires to the terminals. Understood, children? I hope everybody has understood. Very good. Okay, now the electric wires, then how it can be connected? It can be connected to the two terminals of a torch by using adhesive tapes also it can be connected. So this is how we will connect a insulated wire which is having bare ends without insulation. Okay. Now I'll be answering or I'll be asking you some questions. Let's see if you know it. Why does any electrician use rubber gloves while repairing any electric switch at your home? Anybody has any answers, children? I would love to hear your answers. Any answers, children? Why does an electrician use rubber gloves while repairing an electric switch at your home? Why? Why? Because electricity is conducting, and that will, if we are using the electricity, or when we are repairing the electric appliance or any electric connections, what will happen that time? There will be high chances that we will get shock from that electric wire, because maybe sometimes the switch will be on, sometimes the switch will be off. Okay, that time we'll be having the conduction of electricity from the wire to our hand. Okay, so to prevent that, we will wear a they will wear a rubber glove. So these rubber gloves, what will happen? It is like an insulator. It will stop the electricity from flowing. Okay, so this rubber is a material that is an insulator, and that is like the rubbers which you use eraser, same material. In that you'll be using a gloves. So like that you can use it, and what you can do, you can actually prevent the flow of electricity from the wire to your body. Okay, so why this is happening? Because your body is also a very good conductor. Okay, so whenever you touch any appliances, or when any electricians comes to your home, you can actually see they are wearing very high booted rubber or high booted kind of insulating shoes and insulating gloves, and that is the material rubber, while they're doing the electrician works. Okay, so now next question I'll be just asking, do you have any idea why the handles of the tools like screwdrivers, pliers have plastic or rubber cover over them? Any idea? Anybody has any idea why the handles? Some handles, or we use the tools, right? Those handles will be having like plastic or rubber cover over them. Why does that kind of coating of rubber or plastic have that? Any idea? Anybody has any idea? I'm just waiting for some answers. Children, anybody has any idea why that rubber cover is there? Just now we discussed. Remember? For the first question, we discussed about the rubber. So why exactly? I told the answer also. Anybody? Yeah. Let me see some answers. Let me see. Let me see. Okay. Okay. Any idea? Yeah, that is exactly because it is also an insulator. Rubber cover or plastic, they act like insulator, and so there will be stoppage of electricity flow. Okay. Now that is exactly why the tools are having plastic or rubber handles. Okay. Now who will explain to me the working of an electric torch? Who will explain to me? Let's see who understood about this today's class, what we discussed in the electric torch. Who will explain? If you want, I can explain again if anybody didn't understand. So I can explain again. Anybody wants it? So I'll just say again an overview, that is the cells, the terminals of the cell first. Take a cell, the terminals will be there. Two cells, here the positive or negative, it will be there like that. So these two terminals will be connecting to the, what will be connecting to the terminals of a torch. By using what? By using wires. So through these wires, the electricity flowing will be happening from the terminals of the cell to the torch terminal, and that is how the filament of the bulb will start glowing. Understood this much, right? This is like the first point of working of a torch. Now, the second point is the torch when it lights up. Okay, what will happen there? The metal tip of the battery that we had discussed before, the metal tip will be on the up, and the metal case will be on the downside portion. So those will be connected through wires. Okay, so that will be connected through wires, and that is how the flow of electricity will be happening. Then what will happen? Then the electric current will pass from the yes, exactly. It will pass from the wires, and then it will go to the filament of the bulb. And now when it goes to the filament of the bulb, what is going to happen? The filament is going to get heated up too much? No. So when this heating up of filament is happening, it will become white hot and start giving light. Okay, so when this is starting to give so much of light, what happened? We are seeing the light from the torch. That is exactly how we see the light. Okay, so now here the main important point that you should always remember in the working of torch is that this mainly happens on the heating principle. Okay, why? Because the filament is getting heated up and then it becomes hot and white, and then it'll start giving light. No, so the heating effect will be produced by the electricity from the cell, which will make a torch bulb work and produce light. So this is exactly how the working of torch happens. Understood, children? So I hope this is the clear portion for you. If anybody has any doubt from this, any topics from the chapter we have discussed now, just ask me. So I will discuss it with you. Anybody has any doubt, children? Okay. Let me just check. Anybody has any doubt? Now, let's see some interesting fact that you didn't know about. That is, lightning. No, when the thunder happens, lightning will be coming. So, you have any idea how much is that, the volt or the bolt, and how much miles it is traveling? What is the temperature of it? And again, the heating. Just because we were talking about the torch, you know about the heating capacity. Okay, so any idea about the heating capacity? Anybody, any idea? Lightning, what will happen? It is a discharge of electricity in the atmosphere, first of all. Okay, that is the discharge of electricity in the atmosphere. And the lightning bolt, what will happen? It can travel at around how much miles? 1,30,000. Okay, 1,30,000 miles per hour, and then it will nearly be of the temperature how much? 54,000 Fahrenheit in temperature. So just imagine the speed and the heat and the conducting capacity of a lightning. My God, it is too much, yeah. Okay, so that is like it's like one of the strongest and the most heating capacity of a lightning. Okay, now this electricity travels at the speed of light, more than how much? 1,86,000 miles per hour. Okay, so that much is the speed of the light that is traveling in the lightning. Understood? The power of this lightning and thunder that happens after or before a rain or while the rain is happening. Now, another fun fact we will be learning is that Benjamin Franklin, okay, he is a scientist who conducted or carried out one extensive electricity research. What he did, we will see that is in the 18th century, he was inventing the lightning rod amongst his many discoveries, okay. In the event of a lightning strike, what did he notice? The lightning rod conducts the strike without a grounded wire, and that protected a building. So this is one amazing discovery of Benjamin Franklin. I think we all should remember this, right? Because out of so many experiments he conducted, he did one thing, that is he protected the building through the strike of a grounded wire. Okay, so that is a fun fact we learned. And what all did we learn today, children? What all did we learn? Anybody, any answers? I'm waiting for some answers. So Vijay Pandav is saying hi, hi Vijay, how are you? So Vijay, do you know the answers of what we learned today? What is the difference between electric cell and battery? Then we learned about dry cell. Why is it called a dry cell? Then we also learned the impact on dry cell if we join both terminal directly through the wire. What will happen? What exactly will happen? The cell will get used up very easily and very fast, and will get damaged. Okay, so never we have to do that. Then so what is torch? Torch is when two battery, two cell is connected together, and there is conduction of electricity, and the filament will get heated up, and that is how we get the light. Okay, so working of torch also, I think we have discussed it twice. Then insulation of conducting wires. Remember what we told, there is insulating capacity in the rubber content or the rubber material or the plastic material. And the ends, the bare ends will be connected by using an adhesive tape. Okay. So these are some of the topics that we learned today. And I hope everybody enjoyed it. So any doubt anybody has? If everybody is very comfortable with the topic or has any doubt, you can just ask me here in the chat box. Anybody has any doubt? Okay, I'll just go through the slides. If anybody has any doubt in this, children, what we learned today? All good, right? So yes, let me see. Vijay is asking me, how are you? I'm good. How are you, Vijay? Okay. So yeah, I think if nobody has any doubt, let's just wind it up. How about that, children? So how do you like the Swiflearn classes, the live classes that is happening? I would love to know your answers. Okay. Anybody, how's the Swiflearn classes, live classes helping you out? How's it going for you? I would like to know. Anybody can give your opinion in the chat box. I'll be reading it aloud. Okay, fine. So I think everybody's enjoying it, right? You're getting all these portions which you wanted to learn in the video wave in which amazing teachers are explaining it to you. So I think that is good. Very good, children. So I hope everything what we learned today is clear for everybody. And I hope nobody has any doubt because nobody had asked me any doubt here. So I think it's time we wind it up. Yes, children, shall we wind it up? I think then that's it. We had an amazing interactive section of the electric circuit third session. And yeah, take care, everybody. Learn your lessons. If you have any doubt, come back to your Swiflearn live classes. Keep watching, and then again, you can keep learning what you have doubt and anything you want to clear all by yourself. So yeah, that's it, children. Thank you so much for watching. And if you liked what you watched, and if you felt the session was useful, or you got some knowledge, or your doubts got cleared, or it was interactive, you can then subscribe to our Swiflearn channel, and you can also press the bell icon. Why? Why you want to press the bell icon? So you will never miss the update. Okay. If you're getting any live class about any topic, or if it is a topic that you wanted to learn, or if it's a topic that you once studied but you forgot and you want to have a quick revision, so all these updates you will be getting, whichever chapter, whichever lesson is being taken that day and which time, all that update you'll be getting if you press the bell icon here. So that's it, children. If you like the video, you can like it, comment, then share any videos, any Swiflearn live videos you're liking. So that's it, children. Bye, everybody. Take care. Good night. Have your dinner, then sleep well. Bye, everybody.